Cloud Speed is your gateway to AI and the cloud.
Welcome back to Cloud Speed. In this project, we want to run an AI application on the GPU-enabled EC2 instance. In our previous projects, we have been able to run AI applications on CPU-enabled EC2 instances, and it was really slow. So this project, we use GPU instances because GPU are the best resources for running AI workloads. I have been able to create a step-by-step documentation for you to follow through with this project. All you need to do is to check out the description of this video and you will see the link to the GitHub repo is on the docs folder of that GitHub repo. So please follow through the description and you can clone the repo and get the documentation. So we'll start next. The first step in the documentation is to create the EC2 instance, and we need an high performance instance, at least 16 gigabytes of memory with GPU enabled. On AWS, there are several GPU enabled instances, but we'll be using the G instance type. So let's get started with creating the instance. But first of all, let's go to AWS dashboard and then we can go to the service quota. To get the service quota, you can click on the search bar at the top and search for service quota. Then you get to the dashboard of the service quota. The aim of using the service quota is to confirm that you have access to G-type instances. What AWS does is that for new accounts, you don't have access to G-type instances. You only have access to CPU instances. To get access to G-type instances, you request access to G-type instances, which you can see below on quota request history, and then or you click on the type instances where it will be 0, then you can see the button to request access. You'll be sent to the support page. So for us, let's quickly click on define services. We'll put in G, which will enable us to search for the G-type instances. As you can see, we have access to the G-type instances, but for spot instance, this is different from the on-demand instance. So we can't really create a G-type instance for on-demand with our account. We can only create with a spot instance. But this is good enough for us, as we can also use the spot instance to complete the project. If you don't have access to G-type instance, I recommend that you request access to it by clicking on the G-type instance and then you see the button. I previously made a video about requesting access to GPU-enabled EC2 instance. I will put the link on the description of this video, so please check it out. After you confirm that you have access to G-type instances, please you can then go to your EC2 dashboard. Search for EC2 on the search bar at the top. Also confirm that you are in the right region for your EC2 dashboard because the instance types are region specific. If you don't have access to G-type instances on a particular region, you won't be able to launch G-type instances on that region. So for us, we had access to G-type instances on US East 2. So we have to confirm that our region is set to US East 2. After that, then you can go ahead and launch your instance. Let's name our instance Cloud Speed. Then next, we can go ahead and select the instance type. So the instance type is G5 extra large instance. Before we launch our instance, let's check out the instance type on AWS documentation. So search for G5 instance on Google. As you can see, the G5 instance has the NVIDIA GPUs, which we will need to process our inputs from our application. Other AWS instances have different types of GPUs, maybe from A and B. But for this case, we are using the NVIDIA GPUs for G5 instance. Please, I recommend you to go through the documentation to get any necessary details you might need. But I'll close it now for myself and get back to launching the instance. So let's get back to creating our instance. Next, we need to create our key pairs. These key pairs are the secret information which you need to grant access to your servers from your local computers. So we can name it cloud speed. Then you can download it. It will be downloaded to a folder in your local computer. Ensure you have the right settings for your security group. You should allow SSH, HTTPS, and HTTP. These are necessary for you to connect to your instance. Next, we configure the storage. We'll use a 20 gigabyte storage, which is highlighted on the documentation. Then now we need to go to the advanced details. Because we don't have access to on-demand instances on AWS or for this account, we'll need to select spot instances. Now confirm you have just one number of instances. Then you can launch your instance. Your instance is currently launching. Let's get back to the documentation. The next thing for us to do is to copy the files from our local computer to our EC2 instance. At this point, we need to get the IP address of our EC2 instance. Then we need to update it on the command on the documentation. I prefer to update it directly on the documentation so I don't run into issues later on. Okay, I'm using VS Code in this case. I'll quickly go through some of the files so we can know what they contain. So let's see the Docker Compose Ollama file. Then we can see the Docker file.ollama. You can see the NVIDIA GPU's description there. You can as well look at the model we are running, which is Gemma 3. In the previous projects, we have usually run DeepSeek, but I decided to switch in this case to use Gemma. We are using Gemma 12b, but you can as well see the other options for Gemma. I particularly recommend you use the model size I used in this case because it's well suited for the capacity of our server, so you don't run into issues. Let's check out the other files on our repo. So we can look at the FastAPI Ollama.py file. Yeah, we clearly describe the model we are using here. So what we can do is to open our terminal so we can start running the copy command. So we can copy the files from our local computer to our EC2 instance. Ensure you use the right directory for your key pair. I have previously copied the file to the right directory. Okay, next on our documentation is to connect to your EC2 instance. This again requires us to update the IP address on our command. And of course, I'll update it directly on the documentation. All right, now we can run the command to connect to our EC2 instance through SSH. and we have successfully connected to our EC2 instance. We can confirm that the files are well copied to our EC2 instance. Let's get back to our documentation. The next is to connect our DNS directly to our EC2 instance. Our DNS is our domain name. We do this by copying the IP address of our EC2 instance and then updating it on the root value of our DNS. So you simply put in the IP address on the value box and you save it. It's updating. When you update your IP address on your DNS, I recommend that you confirm that it's connected properly and it's well written in the documentation. You use the command nslookup, then the domain you are using. We can run this on command prompts. Now we can confirm that the IP address of our domain name is the same as the IP address of our server. Let's get back to the documentation. The next thing for us to do is to install Docker. So we have to run these whole commands we see below just to install Docker. So I'll quickly pass through it. After installing Docker, you can confirm the version of your Docker. What you can do is to exit the terminal. Then you can log back in to ensure your commands have taken effect. So we are working with G-type instances, which has NVIDIA GPUs. We need to confirm our server can detect our GPUs. To do this, we run the command and we figured out that our server still cannot detect the GPUs. So we need to install the kernel modules and the development tools. And we need to disable some drivers. We would also need to download and install NVIDIA drivers. So I run through some errors while going through the project and I had to update the commands I use in the documentation. So if you follow through the projects, you won't go through the same errors. When you download and install the NVIDIA driver, choose NVIDIA proprietary when prompted and reboot the system so your changes will take effect. Now you can confirm the NVIDIA driver is installed, but that's not all. We also need to install NVIDIA Container Toolkit. Okay, I had to skip through the whole installation of the NVIDIA containers, the drivers, and the kernels. When you are done with that, you can quickly start your containers accordingly. You don't need to start Traefik separately, as Traefik is dependent on FastAPI, and so it will automatically start. After starting your containers, please run docker ps to confirm that your containers are up and running. So please check the logs so you confirm the container is running properly. Now our containers are up and running properly, we can go ahead and test our API. Okay, starting with the test of our API, we'll try to access the root endpoint. When we access it, it will give us FastAPI is running, which is what we got below. The reason it gave us FastAPI is running is because the route endpoint does not communicate with Ollama. To actually communicate with Ollama, which is to prompt our AI model, we'll go to the generate endpoint. The generate endpoint is what communicates with Ollama. Still on the repo, which is linked on the description, you can go to the app folder. There you see the app.py and the query.py. These are actually our front-end files. I recommend you go through the files properly and understand them. Now I can start the front end using this command given on the documentation. You can see our front end is running and it has successfully started. We can start prompting our AI model. You can see it's really fast. Yes, it's way faster than when we use CPU-enabled EC2 instances. You can go through tons of prompting your model and getting responses. One thing I notice is when I give it text-AV prompts for CPU-enabled instances, it usually does not respond as my server crashes. But for the case of using GPU-enabled instances, you can see the AV response it was able to bring back because of the GPU, and the server did not crash. I still continue to prompt it. So go to the documentation. You can see this command to see the metrics of your GPU. What we can confirm here is to ensure and rather confirm that our AI model is actually running on our GPUs. We can give our AI model text-heavy prompts, and then we can see the metrics to confirm that the model is actually running on the GPUs. So let's try it out. The metrics we are looking at for is the temperature and then the power. As you can see, the temperature and the power decreases. This indicates that our AI model was actually running on our GPUs, and now it has completed the task we gave it. So thank you for following this project. Like I mentioned initially, the documentation and the repo for this project is given in the description. The documentation is actually on the docs folder of the repo. So if you clone the repo, you equally have access to the documentation, so you can follow through step by step. So what we can do is now is we can terminate our EC2 instance just to reduce cost, because GPU enabled instances are way costlier than the non-GPU enabled ones. That's why you have to request access to it. Our next project on the series is to run our AI application on Kubernetes. For the node group of our Kubernetes, we'll be using GPU enabled instances as well. So please stay tuned so you can follow through that project as well.
CloudSpeed is your gateway to AI and the cloud. We make videos showing you the latest in tech, and we break down the real-world use cases. If you found this helpful, hit that subscribe button and tap the bell icon so you don't miss any updates. Thanks for watching.